Today in this video, we are going to talk about the alkalis and their differences, its difference with the base. So what is a base and how are the alkalis different from base and how are they different from an acid and what are their reactions? So this is what is going to be in this particular video. We need to understand that bases is a broad terminology, is a broad category of the substances. Now, bases are the substances which are basically your metal oxides or they are metal hydroxides. So all the elements which are belonging on the left hand side of the periodic table, sorry, on the, yes, on the left hand side of the periodic table, right? They are basically your metals, and all the metals, whether they are the transition metals or a typical metal, their oxides and the hydroxide is actually known as bases. Now, among those bases, the ones which are soluble in water, all those bases which are soluble in water, we call them alkalis, right? So basic difference between a base and alkali is just like, for example, we have alphabets A to Z. Now, among this alphabets A to Z, we have vowels A, E, I, O, U, right? So out of these 26 alphabets, we have this just five which are known as vowels. So these vowels also are basically alphabets. So similarly, the bases is a bigger category, which has among these bases, the ones which are soluble bases are actually termed as alkalis. I hope I'm clear. So the soluble bases, the insoluble are still known as bases, but the soluble bases will be known as alkalis. So here is a basic difference between a bases and alkalis. The first difference is that the bases do not dissolve in water. So all those metal oxides or metal hydroxides which are insoluble in water come under the category of bases, and the ones which are dissolved in water, they are specifically known as alkalis. So all are bases, but the ones which are soluble in water, those bases we call alkalis, right? So all the bases are not alkalis. We need to understand that bases are not alkalis, but alkalis can be bases, but alkalis can be bases. As I gave you the analogy, so A to Z are alphabet, but out of these alphabet, those five A, E, I, O, U are basically vowels. So A, E, I, O, U are a part of the alphabet. Similarly, the alkalis are the part of the bases, but bases are not alkalis. We need to understand both the bases and alkalis then neutralizes the acid. They are the chemical opposite of an acid. Now alkalis, because they're soluble, so they give OH positive, OH negative ion in aqueous solution. So how do we define alkalis? Like for example, acids, they basically give you, we say that the acids are one which give you H positive ion in an aqueous solution. That's a definition of an acid, which I've explained in the video when we are talking about acids and the chemical property. Or we can say that they are proton donor. Okay, the acids ki definition may we have said there are two definitions. The first definition says that the one which give H positive aqueous in aqueous solution are acids. Number two, the second definition says that which are proton donors are basically your acids. Now, when we talk about an alkali, the alkalis are defined as, we define alkalis as they are the ones which give you OH negative. The alkalis are the one which give you OH negative ion in an aqueous solution, or the second definition is that the one which accepts the proton. Similarly, like acid, they're chemically opposite of an acid. So if the acid is giving H positive, so they're giving OH negative in aqueous solution. If they're proton donors, and alkalis are basically proton acceptors, they are chemical opposite of an acid. Now, examples of a bases, these are definitely the insoluble. That is why they are under the category of bases. We have zinc hydroxide, copper oxide, and among the alkalis, we have potassium hydroxide and sodium hydroxide. So these are some very common examples of your acids and bases. So this slide also tells you what are bases and what are alkalis. So once again, let's have a recap. So the bases are all the metal oxides and hydroxide are bases, right? This means that the bases contain either the oxide ions or they contain the hydroxide ion, whereas the alkalis are, this is something which need to be focused on. They are soluble in water and they give you OH negative in aqueous solution. Now we have all the metal oxides and hydroxide, which are basically your now, since the metal oxides and hydroxides, they are termed as metal oxides or metal hydroxides are basically known as your bases, right? They are known as bases. The soluble ones are known as alkalis, but still we need to know exactly what is the position of which metals, oxides and hydroxide are soluble. So I'm just letting you know the positions of the metal oxides and hydroxide in the periodic table, which will be soluble one. So we can say that all the group 1 metal oxides or their metal hydroxide, all the group 1 metal oxides and metal hydroxide, group 2, leaving the first two element of the group 2, the rest of them, all the group 1, right, leaving the first two and the rest of them, they are basically your alkalis, right? So all the group 1, that includes your lithium oxides, your lithium hydroxide, your sodium oxide, your sodium hydroxide, okay, then you have potassium oxide, then you have potassium hydroxide. Similarly, leaving the first two in the group, the remaining, the calcium oxide, calcium hydroxide, barium oxide, barium hydroxide, all these are basically alkalis, right? The remaining ones which are belongs to group 2 and which belongs to the transition metal. After group 2 we have the transition metals, right? So after group 2 we have the transition metals. So transition metals and the group 3, these are actually going to form, they are actually going to form the transition metals, and also the group 3 elements or the metals, they will be forming basically the bases. So the purple color, the ones which are in red, the group 2 first two, all the transition metals, all the group 3, they are going to form bases. Only your group 1, only your group 1 metals, only your group 1 metals and group 2, which are below the second element and below, they will be forming your alkalis. So this is actually what you need to know about the position of. And apart from of the alkali, apart from that, we have also known one more alkali, that is known as ammonium hydroxide. Ammonium hydroxide is also known as aqueous ammonia. So if you see anywhere written aqueous ammonia, it means they're talking about ammonium hydroxide, which comes under the category of an alkali. Okay. So if we need to define the alkalis, so we'll say that the alkalis are the substances or they are the chemicals which give hydroxide in aqueous solution because they are soluble in water. So we'll say that the alkalis are the one which produces hydroxide in aqueous solution, right? So here is an example. This is a group 1 metal, sodium. So when the sodium oxide or hydroxide, when you dissolve that in water, it will be giving you sodium ion and it is going to give you the hydroxide ion. The presence of the hydroxide ion is going to give it an alkaline property. The presence of the hydroxide ion is going to give it an alkaline property. Similarly, like the H positive ion in an aqueous solution give any substance an acidic property. Similarly, if you have a hydroxide ion in an aqueous solution, it is going to give it an alkaline property. As we have categorized the acids on the basis of their strength, when similarly we can categorize the alkali on the basis of their strength, we can categorize in them into two categories. So we can say that the alkalis are your strong alkalis and you have weak alkalis on the basis of the strength. On the basis of their strength, the alkalis can be defined as strong acid and strong alkalis and weak So alkalis on the basis of the strength of OH ions, on the basis of the strength of an OH ion in the aqueous solution, we can define them, we can categorize them as a strong alkali or a weak alkali. Similarly, as we have categorized the acid as a strong and the weak acid. And you can, this have already been explained in the video where I'm talking about where I'm introducing the topic acids, or I'm talking about the properties of an acid. Like similarly, we have got a strong alkali. Strong alkalis are the ones which give you the maximum OH ions, and the weak alkalis are the one which give you few OH ions. Now, definitely the strong alkali will be having a higher pH. The maximum pH on the pH scale is basically 14. So the strong alkalis are going to give you a higher pH of 13 or maybe 13 point something up till 14. Whereas the weaker alkali will be giving you a lower pH, right? So they will, because they have the few OH ions, and because they have the higher pH or they have the maximum OH ions, hence we can say that the conductivity, because they have more ions, so the conductivity is more. And because the weak alkalis have got few OH ions, so the mobility of these OH ions, because they are few in number, तो उसकी वजह से conductivity is going to be low, right? Now, I was explaining that why aqueous ammonia or ammonium solution, why aqueous ammonia, or we have ammonium hydroxide, right? Ammonium hydroxide is categorized as a weak alkali. The strong alkalis are those which get fully ionized. It's 100% getting ionized. If we take the strong alkali, like the group 1 alkalis, group 1 hydroxide are always strong. So if we take an example of sodium hydroxide in and we dissolve that in water, this is going to give you 100% ions of sodium ions and hydroxide ion. That means if I have 100 molecules of sodium hydroxide, you will be getting 100 Na positive ion and 100 OH negative ion. So this is completely, so we'll say that all the strong alkalis are going to ionize, they are going to completely ionize in water. So this is 100% ionization. So they undergo 100% ionization in water, and that is the reason they are considered as strong alkalis, right? They're considered as strong alkalis. Why? Because they undergo complete ionization. Now, similarly is for the rest of the group 1 also, to potassium hydroxide, lithium hydroxide, rubidium hydroxide, and the remaining. They all are very strong alkalis. Now, when we move on to the second scenario is of the weak alkalis. So under the category of the weak alkalis, we have ammonium hydroxide, or we have ammonium hydroxide, a weak alkali. And the second weak alkali, we have calcium hydroxide, that is also a weak alkali. Now, why are they considered as a weak alkali? Right? They're considered as a weak alkali because they undergo partial ionization. What do we mean by partial ionization? Partial ionization means that they are going to undergo a reversible reaction. That means this the aqueous ammonia is going to split up into ammonium and hydroxide ions. But what will happen? In this reaction, the ammonium and hydroxide are going to combine back to give you molecules back again. Okay, this is undissociated molecules back again. So this reaction is going in the forward direction, and when the ions are being formed, they combine together to give you undissociated molecules. So that is the reason that at one particular point you never get 100% ions present, and that is what we call partial ionization. So all the alkalis which give you the partial ionization are considered as weak alkalis, and the ones which undergo an irreversible reaction, it is undergoing an irreversible, that means it's undergoing only the forward reaction. There you're getting the 100% OH negative ion in aqueous solution at one particular point. So we call them completely ionized, and because they have the 100% ionization, we call them strong alkalis. So all the group 1 alkalis are considered to be strong alkalis, and the group 2 or aqueous ammonium ions are considered to be the weak alkali. Okay. Here are some of the properties. Here are the some of the physical properties of an alkali. Now, they are chemical opposite of an acid. So they, when you talk about acid, though we never try to taste them, but the natural acids, which are the organic acids, they are sour in taste. Similarly, the alkalis are going to be bitter in taste, and they're soapy to touch, right? So they are these are two different properties. The alkalis have bitter taste and they're soapy to touch. Apart from that, again, because they are chemically opposite of an acid, so acid turns litmus paper, the blue litmus paper, acid turn blue litmus red, right? Similarly, opposite of this, what will happen? They are going to turn blue litmus red. Now, what will alkali do? The alkali is going to turn red litmus blue, right? And the third property is that this is not the property, right? They will be, third property is that they are good electrolytes. What do you mean by they are good electrolytes? That means they are going to conduct electricity in the aqueous solution, right? So they act as a good electrolyte. So these are physical properties. Now let's talk about some of the uses of bases and alkalis also. So here are some of the uses of bases and alkalis. Number one, let's talk about magnesium hydroxide. Magnesium hydroxide, it's used in toothpaste to neutralize the acidity of the mouth. So it is used to, so the toothpastes are alkaline in nature because they have magnesium hydroxide present in this. Then we must have heard of milk of magnesia. So milk of magnesia is anti-acid. So if you have an acidity in your stomach, so basically you consume as a medicine the milk of magnesia. You call it milk of magnesia, right? So this is an antacid which actually neutralizes the acidity which is being formed in your stomach. So this is a very important use. Then the use number three is that because they're soapy to touch, so they are used for making soap and they're used for making detergents and industrial cleaning detergents. So if their industrial discharge, if your industrial discharge is basically acidic in nature, so before disposing of that discharge, they are being treated with an alkali and then disposed of. So this is, they are also used for the industrial neutralization or industrial detergents. Then we have the use number five. That means the aqueous ammonia is again used as a cleaning solution. It's very mild acidic alkaline, or it's a weak alkali. So you're using a mild alkali in order for the window cleaning, etc. And it is also used for making fertilizer. That is a very important use. We'll be talking about this fertilizer making in another chapter known as Haber process. Then comes a very important use of calcium oxide, which is again an alkali. It neutralizes the acidic soil. So when acid rain take place, तो acid rain क्या करता है? Acid rain जो है वो आपकी soil को acidic करता है. So if the farmer need to have a pH, need to neutralize the soil, so he has to spray calcium oxide over the soil in order to neutralize it, right? Then it is calcium oxide is also used to make iron, concrete and cement. So that's the use number 8. So you need to know some of the uses of alkali or basic specifically, and examiner often ask you 1 mark question related to the uses or the physical properties. Okay, here are the chemical properties. So this is a chemical property number 1, the chemical properties of alkalis, right? So this is property number 1, right? So when a base or an alkali, they react together, you get salt and water, right? So metal oxides or a metal hydroxide, which are known as bases, and the soluble one are known as alkalis. When they react with an acid, right, they give you salt and they give you water. Here you have an example of an alkali reacting with an acid, and here you have a base reacting with an acid. You're getting corresponding salt. Here you're getting sodium chloride. In the other scenario where you have a base, copper oxide, as I told you, all the transition metal oxides and hydroxide they'll be forming, they'll be known as the bases because they are not soluble. So copper oxide or zinc oxide or lead oxide, they'll be giving you the corresponding salts with the acid, and they'll be forming water too. Now, after this, we move on to something very important, which is practically very important reaction, the reaction number 2 of alkalis. Okay, this reaction is extremely very important, that whenever the alkalis, they react with ammonium salt, whenever the alkalis, they react with ammonium salt, they give you, they drive out ammonia, they give you salt, they give you water, and they give you ammonia gas, right? So whenever the alkalis, they react with the ammonium salt, they give you salt, they give you water, and they give you ammonia. This is ammonium salt. These are basically ammonium salt. Now iska jo ek application hai wo ye hai ki, for example, agar many a time it happens ke, and this is also a lab preparation for ammonia gas. If we need to prepare the ammonia gas in the lab, this is how we prepare the ammonia gas in the lab, right? इसकी एक practicality ये है कि अगर for example farmers जो हैं वो normally they add the fertilizers, and the fertilizers are your ammonium salt. That can be ammonium chloride, that can be urea, which is again an ammonium compound, ammonium sulfate, in order to enrich the soil in the nitrogen content. ठीक है, तो ये आपका fertilizer के तौर पे आप use कर सकते हैं, right? So all the ammonium sulfate, all the ammonium salts are basically used as fertilizers, right? तो अगर एक farmer ने अपने farm area पे fertilizer spread करा और उसके बाद acid rain हुई, और acid rain के बाद soil acidic हुई, तो definitely farmer is going to treat the soil by an alkali, right, in order to neutralize the acidic soil. तो उससे उसका effect क्या होगा कि farmer ने पहले जो है वो fertilizer add किया, और उसके बाद फर्टिलाइजर्स, और उसके बाद एसिड रेन हुई, और एसिड रेन की वजह से आपकी सॉइल जो होगी वो एसिडिक हो गई, ठीक है, द सॉइल टर्न एसिडिक. नाउ व्हाट इज ही डूइंग टू द एसिडिक सॉइल? ही इज adding calcium oxide, or he's adding calcium hydroxide in order to neutralize the soil, right? So the fertilizer is already there in the soil, so what will happen? And he's adding the fertilizer increase in order to increase the nitrogen content of the soil, in order to increase the nitrogen content of the soil, right? क्योंकि आपकी एटमॉस्फेरिक नाइट्रोजन जो होती है वो आपका ट्रिपल बॉन्डेड नाइट्रोजन होती है, जिसका बॉन्ड इजीली ब्रेक नहीं होता. तो ये एटमॉस्फेरिक नाइट्रोजन इज यूजलेस, वो उसका कोई भी सॉइल में फिक्सेशन नहीं होता. तो नाइट्रोजन को फिक्स करने के लिए सॉइल के अंदर आप हमेशा फर्टिलाइजर ऐड करते हैं, ठीक है, और नाइट्रोजन जरूरी होती है फॉर द प्रोटीन सिंथेसिस, ठीक है. Nitrogen is important for the protein synthesis, right? So the farmers normally add nitrogen through the nitrogenous fertilizers, which are basically your ammonium compound. तो अब उन्होंने fertilizer, पहले स्टेप में fertilizer ऐड किया, उसके बाद acid rain हुई, ठीक है, एसिड रेन को उन्होंने ट्रीट किया विद एन alkali. अब हुआ क्या? बिकॉज ऑफ दिस व्हाट हैपेंस, the fertilizer and an alkali will react together. Now when they'll react together, the ammonia will be discharged. जब ammonia discharge होगी तो क्या होगा? The nitrogen content of the soil will decrease. जो उन्होंने add किया था fertilizer just to increase the nitrogen content, अब वो नाइट्रोजन कंटेंट क्या होगा? दैट विल अगेन लोअर डाउन, दैट विल डिक्रीज. तो क्या फर्टिलाइजर डालने का कोई फायदा हुआ? फर्टिलाइजर डालने का कोई फायदा नहीं हुआ, क्योंकि जितना भी फर्टिलाइजर डाला था वो अमोनिया गैस बन के निकल गया. तो नाउ इन ऑर्डर टू रिटेन द फर्टिलाइजर इनटू द सॉइल, फर्स्ट द सॉइल शुड बी ट्रीटेड. After treating the soil, now the fertilizer should be added. Otherwise, there's no point in adding the fertilizer. So they ask you a past paper question, a similar, I'll show you what question, right? So it is related, and they ask you why is it so, why the nitrogen has been lost. So this is the reason why the soil will be losing the nitrogen content. So here is a question which is from the year October, November 17, and it's question number 8, just one part of that. It the question says that concentrated aqueous ammonia is used to make fertilizer, and the fertilizer is basically an ammonium compound, that's ammonium phosphate, NH4 whole thrice PO4. Now they're asking you explain why. You have to give the reason why adding calcium hydroxide to the soil at the same time as ammonium phosphate results in the loss of nitrogen from the soil. And it's a 2-mark question, right? So the examiner is asking, why is it so? So what explanation you will say, you give. So the explanation which you'll be giving here for the 2-mark question is that whenever the ammonium compounds, they react with an alkali, whenever the ammonium compounds, they reacts with, or ammonium salts, they react with ammonium salts which act as a fertilizer whenever which act like a first fertilizer when they react with an alkali, right? They give you ammonia as a gas. So when ammonia is liberated as a gas, that reduces the nitrogen content of the soil. The ammonium salts, which you're adding as a fertilizer to increase the nitrogen content, on adding alkali, they releases ammonia gas, which leads to the loss in the nitrogen content. So this is a 2 mark question. So the second property is very important related to this. इससे related इस तरह के questions आते हैं. I hope I'm clear.